Hello, my name is Christopher Linford, and today I'll explain common pitfalls of recursion and how to overcome them. Now, before discussing the pitfalls, I want you guys to understand what recursion is, as well as the two base or main rules for recursion. So number one, recursion is the calling of a function with the same function. So this can be used to solve problems by identifying a solution which is written in terms of solving the same problem using smaller values. So that kind of will lead us into the two different rules. The first one is for every recursive function, you need a smaller version of the problem. If the problem does not get smaller, the function will keep calling itself forever, which is a bad thing. And the second thing we need is a base case. So every function must have a base case. It's the condition that stops the recursion from going on. So without a base case, it'll just keep going on and on forever. We can give a simple example of this. The example is a factorial function. Mainly with the factorial function, you multiply all the numbers by the numbers below it. So 5 factorial is 5 times 4 times 3 times 2 times 1. If we do a recursion example, we can define it as n factorial equals n times, or n minus 1 factorial. Why does this work? Because the problems keep getting smaller until it reaches the base case, which is 1. Now, for the two different questions, the pitfalls that we get with recursion and how we can solve them. The first one is stack overflow. So this happens when a recursive function calls itself too many times without stopping. It uses too much memory on the call stack, and it goes on too deep, and the program can just crash. Why does this happen? There's no proper base case, or the recursive calls are not reducing the problem in size. What do we do to overcome it? To fix this, we need to follow the rules of recursion carefully. Get a clear base case that stops the recursion, and then second, make sure we get the base case that stops the recursion. Second, we want to make sure the recursive call moves the base by reducing the problem size. Now, if the problem is too deep and such, we can go to an iterative approach, like using a loop stack, which could avoid the stack overflow. Now, the second one would be recomputing the same work. So what does this mean? With recursions, it kind of goes over and over, and repeated calculations take memory, time, etc. Example, the Fibonacci sequence. You're going to recalculate the values over and over, like many times, and it's very slow performance, especially if you have large inputs. What do you do to overcome this? We use memoization. Mainly, memoization means you can store the previous computed results and then use those instead of doing the recursive function of recalculating the stuff over and over. You can put the results, say, in a dictionary, and when you need to use the results again, look it up instead of recomputing it. And then another approach is dynamic programming. Just solve the problem iteratively and build the solution step by step. So what are some examples of real-world recursion? One of my favorite is the binary search tree. With the binary search trees, it's already sorted in half, meaning the algorithm can just keep going on the half and avoiding the other places where it doesn't need to, and it gives you a cool, fast, big O time of O log of n. So in conclusion, recursion is a powerful tool, but it comes with challenges. Challenges are stack overflow. If it runs too deep, this is efficient if it keeps repeating the same work. And then the second one is just the recomputing the same work. So how do we avoid these problems? Make sure you're using the proper recursion rules, so have proper base cases, the problem gets reduced in size, and then use proper applying techniques like memoization, iteration. Thank you.